Okay, we'll start. Okay, so we have completed question number 5. Sorry, sub question 3 of question number 5. We need to start from question number 4. So fourth one, 1 plus ck divided by ck equal to sine square a by 1 minus cos a. So we need to prove that 1 plus ck by ck equal to sine square a by 1 minus cos a. So we'll start from LHS and we will get a value, and after that we'll solve RHS. Again we'll get a value. Finally we'll see whether LHS equal to RHS or not. So first we'll start with LHS. 1 plus ck by so below that, guys, we're gonna change ck to 1 by equal to 1 by cos a. Then change sec in numerator and denominator as 1 by cos a in the next step. So it will be 1 plus 1 by cos a divided by sec is 1 by cos a again. Now here you take the LCM. Multiply by cos a in the denominator and multiply by cos a on the numerator. So 1 into cos a plus you have 1 here. So cos a plus 1 divided by here also cos a, here also cos a. So you can write a common cos a divided by, see here, 1 by cos a. So by taking the LCM, you got cos a plus 1 divided by cos a, again whole divided by 1 by cos a. So in the next step, I will be taking this denominator 1 by cos a into this side. So it will be reciprocal cos a by 1 and this division will become multiplication. Okay, so you got cos A plus 1 by cos A divided by again 1 by cos A. Now I am taking this to this side. So your next step will be cos A plus 1 divided by cos A. Then that multiplication, sorry, division will be multiplication here, and take the reciprocal of the denominator, that is cos A by 1. See, now you can cancel this cos A from denominator side and from numerator side. Cos A got cancelled. So what is remaining? Only cos A plus 1 equal to cos A plus 1. So this is your LHS value. Now we'll solve the RHS side. So copy down till here.
Yes, ma'am.
Yes, ma'am. RHS side. So now write RHS. So your RHS is sin square A divided by 1 minus cos A. Now we'll solve the RHS side. Sin square A divided by 1 minus cos A. So from identity number 1, we know that sin square A plus cos square A equal to 1. And also you can write sin square A equal to 1 minus cos square A. So below this write changing sin square A equal to 1 minus cos square A. So in the next step, change sin square A as 1 minus cos square A. So it will be 1 minus cos square A divided by 1 minus cos A. Azam, you are little late. We have already started the question. Question number 4.
Okay, ma'am.
Okay. Okay, shall we start from the beginning? Because Azam joined now.
Yes, ma'am.
Yes, ma'am. Okay, sub question 4 of question number 5. We need to prove that 1 plus ck by ck equal to sine square a by 1 minus cos a. So first of all, we'll start from the LHS side and we'll get a value. After that, we'll simplify the RHS side and finally we'll prove that LHS equal to RHS. So start with question number 4. So this is the LHS 1 plus ck by ck. Now below that, right, we are going to change sec in terms of cos. The reciprocal of sec is cos. So you can write ck equal to 1 by cos a. So below that, right, changing sec a equal to 1 by cos a. So in the next step, it will be 1 plus ck. I am writing 1 by cos a. So 1 plus 1 by cos a divided by ck is 1 by cos a. Then take the LCM here on the numerator side. So 1 divided by into cos A, numerator also into cos A to make the denominator same. Why you okay, so you got cos A plus 1 by cos A again divided by 1 by cos A. So in the next step, I'll be taking this denominator 1 by cos A to the other side. So it will be reciprocal of 1 by cos A. That means cos A by 1. And this division will become multiplication. So the next step equal to cos A plus 1 divided by cos A into reciprocal of 1 by cos A. Cos A by 1. So you can cancel this cos A on the numerator side and cos A on the denominator side. So what else is remaining? Cos A plus 1. So this is the value of LHS side. Now we'll solve the same way RHS also. So the same way write RHS equal to, so what is the RHS value? Sine square A by 1 minus cos A. So we'll simplify this one, sine square A by 1 minus cos A. So I can write sine square A equal to cos square A. Using sine square A equal to cos square A, that is I over 1. So in the next step, right, instead of sine square A, 1 minus cos square A divided by 1 minus cos A. So now you can see this numerator is in the form of another algebraic identity, A square minus B square. See, 1 you can write as 1 square. 1 square is 1. So you can write 1 square minus cos square A. So this is in the form of A square minus B square equal to A plus B into A minus B. So we'll change it in the form of A plus B into A minus B since it is in the form of A square minus B square. So below that, right, applying identity, A square minus B square equal to A plus B into A minus B. Then if you want, right, here A is equal to 1, B is equal to cos A. So this can be written as A plus B into A minus B. That means 1 plus cos A into 1 minus cos A by applying the identity. So 1 square minus cos square A can be written as 1 plus cos A, that is A plus B into A minus B. 1 minus cos A divided by the same thing, 1 minus cos A. Now you can cancel this 1 minus cos A on the numerator side and 1 minus cos A on the denominator side. See what is remaining? 1 plus cos A. So this is the answer of RHS side. So LHS we got cos A plus 1. RHS we got 1 plus cos A. Both are same. 1 plus cos A and cos A plus 1 are also same. So you can write therefore LHS equal to RHS equal to 1 plus cos A. Then write hence proved. So we'll move to the next one. Fifth one, cos A minus sin A plus 1 divided by cos A plus sin A minus 1 equal to cosec A plus cot A using the identity cosec square A equal to 1 plus cot square A. So if you need to apply the identity cosec square A equal to 1 plus cot square A, there should be something in terms of cosec and cot here on the LHS side. But we have only in terms of cos and sine. So first of all, we need to convert it in terms of cosec and cot. So if you want to change it into cosec and cot, we need to divide all the terms by sine. See, cos by sine is cot. 1 by sine is cosec. Then only we'll get cot and cosec. So first step will be dividing all the terms by sine A. So taking the LHS first. LHS is cos A minus sine A plus 1 divided by cos A plus sine A minus 1. Then write dividing both numerator and denominator by sine A. So now we're going to divide all the terms by sine A. So your next step will be cos A by sine A minus sine A by sine A plus 1 by sine A whole divided by again cos A by sine A plus sine A by sine A minus 1 by sine A. So cos A by sin A will become cos by sin is cot A. Sin A will be 1. 1 by sin A. Reciprocal of sin is what? Cosec. So 1 by sin A will become cosec A. Cos A will be cancelled and it will be 1. So your next step will be cot A minus cosec A divided by cot A plus 1 by cosec A minus cosec A. So write the next step. Cos by sin cot A minus sin as 1 by sin cosec divided by same cot A plus 1 minus cosec A. Okay, now listen carefully. According to your trigonometric identity number 3, we know that cosec square A minus cot square A equal to 1. See here in this question they have given cosec square A equal to 1 plus cot square A. This we can write as cosec square A minus cot square A equal to 1 in that way also. So I am applying or replacing 1 as, right, replacing 1 equal to cosec square A minus cot square A. Then write in the bracket identity number 3. So in the numerator side, instead of this 1, in the next step, we'll write cosec square A minus cot square A. We won't write that 1. Equal to cot A minus, instead of 1, we are going to write cosec square A minus cot square A. So write in a bracket cosec square A minus cot square A. Then what is here cos plus cosec A divided by, write the same thing, cot A plus 1 minus cosec A. Don't change this 1 on the denominator side, only change the 1 on the numerator side. Replace by cosec square A minus cot square A and don't forget to put the bracket. See, in the next step, what we're going to do is, we'll rearrange all the square terms together and other non-square terms together. So here you can see cosec square A minus cot square A are together and we'll write cot A and cosec A together in the next step. Simply I'm rearranging both. So next step will be cot A plus cosec A minus cosec square A minus cot square A divided by cot A plus 1 minus cosec A. So for your later reference, you can write there rearranging squares or square terms together. No need to write this in the exam. It's just for your reference. Rearranging square term together in the numerator. Then write cot A minus cosec A minus open the bracket cosec square A minus cot square A whole divided by cot A plus 1 minus cosec A. Okay, now open the bracket. This is in the form of third identity a square minus b square. See, this one is in the form of a square minus b square. So we'll change it into a plus b into a minus b. Next step will be cot a minus cosec a minus open the bracket and write it in the form of a plus b into a minus b. A is what? Cosec a. B is cot a. So a plus b will be cosec a plus cot a into cosec a minus cot a. Whole divided by, write the same thing, cot a plus 1 minus cosec a. So in this step, we have simply changed this a square minus b square form to a plus b into a minus b. We have just applied the identity number 3. Okay, so you got cot a plus cosec a open the big, okay, it minus open the big bracket. Again inside that cosec a plus cot a into cosec a minus cot a. Whole divided by cot a plus 1 minus cosec a. Okay, now you can see inside the bracket you have cosec a plus cot a. Outside the bracket also you have cosec a plus cot a. So in the next step, I'll be taking out the common term cosec a plus cot a outside. So right below, taking out common cot a plus cosec a. So I've taken out cot a plus cosec a outside. So what will be there inside the bracket? See, cot a plus cosec a is cancelled from here. So what is remaining there? Only 1. Then this minus. See here, from inside the bracket, I have again taken cot a plus cosec a. That is also cancelled. So what is remaining there? Only cosec a minus cot a. So 1 minus cosec a minus cot a. So whenever you are writing any negative term, put the bracket divided by cot A plus 1 minus cosec A. Okay. In this step, we have just taken out the common term, that is cot A plus 1. So from here, what is remaining? Only 1 is there. Then minus, inside the bracket here, again we have taken cot A plus cosec A outside. So that is also cancelled. So what is remaining there? Only this one, cosec A minus cot A. That's what I have written here, cosec A minus cot A. And this is the same thing. Denominator is the same thing. Write as it is. Okay, in the next step, I'll be removing this bracket. This bracket I am removing. And what happens to the inside terms? All the sign changes inside the bracket. So when I remove this bracket, this cosec A will become minus cosec A. And this minus cot A will become plus cot A. All the signs will be reversed. So next step, I'm going to remove the bracket. So it will be 1 minus cosec A plus cot A. Okay, now write the next step. Equal to cot A plus, okay, before that write removing the bracket. This is for you to understand. Okay, by removing the bracket, you'll be getting cot A plus cosec A. Okay, we have removed the bracket. That small bracket we have removed, and this big bracket is here. 1. Earlier it was 1 minus, again another bracket, cosec A minus cot A. Now we have removed that bracket, and it will be 1 minus cosec A plus cot A. Change all the side inside the bracket. Divided by same thing, cot A plus 1 minus cosec A. Okay, now see this term and the denominator term. Both are same. Here it is plus 1, here also plus 1. Minus cosec A, minus cosec A. Plus cot A, plus cot A. All the terms are same. So we can cancel both. Numerator it is 1 minus cosec A plus cot A. Denominator it is cot A plus 1 minus cosec A. All the terms are equal. So you can cancel this whole term and this term from numerator and denominator side. So what is remaining? Only this term. Cot A plus cosec A. So whenever you're cancelling two terms, only one term will be remaining. The next one, question number 6. Sixth one, root of 1 plus sin A by 1 minus sin A equal to ck plus tan A. So we'll start from the LHS. Root of 1 plus sin A divided by 1 minus sin A. So the first step will be dividing numerator and denominator by cos A. So we're going to divide all the terms by cos A. So next step will be root of 1 by cos A. Divide everything by cos A plus sin A by cos A. Again divided by 1 by cos A minus sin A by cos A. Equal to, see, 1 by cos A, reciprocal of cos is sec. So 1 by cos A will be ck. Then the next one, sin A by cos A. Sin by cos is tan. So sin A by cos A will be tan A. Right? Root of, right, ck plus sin A by cos tan A. Minus sin A by cos A tan A. So I got root of ck plus tan A divided by ck minus tan A. I think Hibagania just joined the class. So, Gania, we are doing sub question 6 of question number 5 of exercise 8.4. Sixth one, root of 1 plus sin a divided by 1 minus sin a equal to ck plus tan a. So, we just started the answer with LHS. Root of 1 plus sin a by 1 minus sin a. First, we have divided the numerator and denominator by cos a. So all the terms we are dividing by cos a. So 1 plus sin a, it will be 1 by cos a plus sin a by cos a divided by 1 by cos a minus sin a by cos a. Everything we are dividing by cos a. So we got 1 by cos a. See here 1 by cos a, reciprocal of cos is sec. So you can write 1 by cos a as sec. Sin a by cos a is tan a. So I have written here tan a. Same way, denominator also 1 by cos a sec. Sin a by cos a became tan a. Okay, so we got root of ck plus tan a divided by ck minus tan a. Now we're going to rationalize the denominator. So write So how will you rationalize the denominator? See here, the denominator is ck minus tan a. So we'll multiply the denominator and numerator by ck plus tan a. The opposite sign. Here it is minus. So we'll multiply both by ck plus tan a equal to root of ck plus tan a divided by sec a minus tan a. So multiply both numerator and denominator by root of ck plus tan a. Opposite sign of the denominator divided by sec a plus tan a. Now see the numerator. Here you have ck plus tan a into again ck plus tan a. That means ck plus tan a into ck plus tan a. That is ck plus tan a whole square. So this you can be written as sec a plus tan a whole square. Now come to the denominator side. See here it is ck minus tan a. Here it is ck plus tan a. So ck minus tan a into ck plus tan a is in the form of a minus b into a plus b. Algebraic identity number 3. A minus b into a plus b is equal to a square minus b square. So this denominator can be written as A square minus B square means sec square A minus tan square A. Okay, so numerator is in the form of A plus B whole square. Denominator will be in the form of A square minus B square. That's what we're going to do in the next step. Okay, write the next step. Root of ck plus tan A whole square, because these two are same. So ck plus tan A whole square divided by A minus B into A plus B, A square minus B square. So it will be root of, don't cancel the root. So it will be sec A plus tan A whole square divided by A square minus B square form. A is sec, B is tan. So that will be sec square A minus tan square A. See, this is in the form of A square minus B square. This is your next step. So I have told you, if root and square is coming together, you can cancel both. See the numerator. Numerator is having one square here and also a root here. So I told you, if root and square is coming together, you can cancel both. Only for the numerator. In the next step, you can cancel the root and square for the numerator since both are coming together. So you can write simply ck plus tan A without the root divided by root of sec A minus tan square A. So according to the identity number square equal to 1. Identity number 3. Sorry, identity number 2. Square A minus tan square A equal to 1. So you can replace this denominator as 1. Sec square A minus tan square A. Okay, so write, since sec square A minus tan square A equal to 1, then write the next step. The whole denominator will be equal to 1. So the denominator got cancelled. So you'll be getting like this, ck plus tan A by 1. By 1 means what? Ck plus tan A. No need to write that by 1. See the question? We need to prove this is equal to. See here, we need to prove this is equal to ck plus tan A. Here also ck plus tan A, which is equal to RHS, hence proved. Now question number 7. Sorry, that is question number 8. Sine theta minus 2 sine cube theta divided by 2 cos cube theta minus cos theta is equal to tan theta. So as usual, we'll start with the LHS side. Okay, starting with the LHS, that is sine theta minus 2 sine cube theta divided by 2 cos cube theta minus cos theta. Okay, see the numerator. You have sine theta here, here also sine theta. So you can take the common sine theta outside. Sine and sine are common. So you can take one sine theta outside. So below that, right, taking sine theta outside. Okay, in the next step, I have taken sine theta outside. So inside the bracket, see here, I have taken sine theta out. That means this sine is cancelled. So what is there? Only 1. Sine theta is cancelled, so only 1 is there. Now I'm putting minus. Then from here, from this term, I have taken sine theta outside. So here you have 2 sine cube theta. So from that sine cube theta, I have taken 1 sine out. So what is remaining there? 2 sine square theta. 1 sine theta I have taken outside. So only sine square theta is there out of sine cube theta. Divided by, write the same thing, 2 cos square theta minus cos theta. So in this step, I have taken sine theta outside. Numerator. Now sine theta is gone. So there is 1 remaining. It will be 2 sine square theta. Divided by, write the same thing. Denominator 2 cos square theta minus. Sorry, that is 2 cos cube theta divided by 2 cos theta minus cos theta. Again the same thing. We are taking cos theta from the denominator. See here denominator you have cos and cos same common terms. So from the denominator I am taking out cos theta. So your next step will be, okay, below that again, right, taking cos theta out from denominator. So next step we are taking cos theta outside from the denominator. So it is sine theta into 1 minus 2 sine square theta divided by cos cube theta 2 cos cube theta minus cos theta. So I'm taking cos theta outside. So the next step will be sine theta into 1 minus 2 sine square theta divided by, see, I'm taking cos theta outside. So inside what will be there? From 2 cos square theta, I have taken cos theta outside. So one cos is gone. So what is remaining? 2 cos square theta minus. So from this term, I have taken cos theta. So what is there remaining? Only 1. So this is the step. Sine theta into 1 minus 2 sine square theta divided by cos theta into 2 cos square theta minus 1. Okay, next step will be changing this sine square theta. So from identity number 1, we know that sine square theta is equal to 1 minus cos square theta, right? So I'm going to replace this sine square theta as 1 minus cos square theta in the next step. So below that, right, since sine square theta is equal to 1 minus cos square theta, in the next step, you replace this sine square theta as 1 minus cos square theta. Okay. So next step, sine theta into 1 minus cos square theta. So replacing sine square theta as 1 minus cos square theta. So it will be 2 into 1 minus cos square theta. Negative sign here. It's two terms, so you need to put the bracket over there. Divided by, write the same thing, cos theta into 2 cos square theta minus 1. So next step, what I'm going to do is giving this 2 to both the terms. Okay, I'm distributing that 2 into 1 and cos square theta in the next step. So it will be sine theta into 1 minus, see, minus 2 into 1. Negative into positive, negative. 2 into 1, 2. So it will be minus 2. So next one, minus 2 into cos square theta. That will be minus 2 cos square theta. Sorry, that is minus cos square theta. Yeah, that is minus cos square theta. So minus 2 into minus cos square theta. Negative into negative, positive. So it will be positive 2 cos square theta. I'll explain once more. See, I'm giving this 2 to both 1 and minus cos square theta. So it will be 1 minus 2 into 1. Negative into positive, negative. So it will be minus 2. Then minus 2 into minus cos square theta. Negative into negative, positive. So the sign will be positive. 2 into cos square theta, 2 cos square theta. So distributed divided by cos theta into, write the same thing, 2 cos square theta minus 1. Now you see here, you have 1 minus 2. What is 1 minus 2? Minus 1. Right? 1 minus 2 is minus 1. So these two terms will be minus 1. So write in the next step, equal to sine theta, open the bracket. So 1 minus 2 is minus 1. Then what else is there? Plus 2 cos square theta, close the bracket, divided by cos theta into 2 cos square theta minus 1. Now see the numerator and denominator. Inside the bracket on the numerator side, you have minus 1 plus 2 cos square theta. Denominator you can see minus 1 2 cos square theta minus 1 and minus 1 plus 2 cos square theta are same. So you can cancel both. Since the signs are same, you can cancel both. This and this get cancelled. Then what else is remaining? Only sine theta by cos theta. So equal to sine theta by cos theta. What is sine by cos? Tan theta. Sine by cos is tan. So sine theta by cos theta is equal to tan theta. See the question. We need to prove this is equal to tan theta. See, we need to prove it is equal to RHS. So we got tan theta that is equal to RHS. Hence proved. Shall we move to the next question? Okay, now question number 8. If there is any doubt, you can ask me now. Okay, fine. We'll move to the next one. Eighth one. Sin A plus cosec A whole square plus cos A plus sec A whole square equal to 7 plus tan square A plus cot square A. Okay, take the LHS side first. Sin A plus cosec A whole square plus cos A plus sec A whole square. See, both are in the form of A plus B whole square. This one is also in the form of A plus B whole square. This is also in the form of A plus B whole square. So you can expand both in the form a square plus 2ab plus b square. So we're going to expand both together. So below that, write expanding a plus b whole square equal to a square plus 2ab plus b square. Okay, first one is sin a plus cosec a whole square. Here a is sin, b is cosec. So when I expand it in the form of a square plus 2ab plus b square, it will be sin square a, that is a square, plus 2ab, that means 2 into sin into cosec a plus b square. B is cosec. So cosec square a. This is the first one. Now plus second one, cos a plus sec a whole square. That also expanded in the form of a plus b whole square. A square means cos square a plus 2ab. That means 2 into cos a into sec a plus b square, sec square a. So now we have expanded both the terms. Sin a plus cosec a whole square plus cos a plus sec a whole square. In the form a square plus 2ab plus b square. This is a square plus 2ab plus b square. Here also a square plus 2ab plus b square. Now we're going to rearrange all the terms. Since we know all the signs are plus, plus, everywhere it is addition. So we can rearrange it. Then 2 sin A cos A and 2 cos A sec A I'm going to write together. Then square A and sec square A together. Simply I'm rearranging all the terms. See here, next step will be sin square A plus cos square A, sin square A, then from here cos square A. Then I'm writing this one, 2 sin A cosec A, 2 sin A cosec A. Again you have here 2 cosec, what is that? Cos A sec A. So 2 cos A sec A. Then what else is remaining? Cosec square A, sec square A. So plus cosec square A plus sec square A. So from identity number 1, we know that sin square A plus cos square A is 1. So these two terms will be equal to 1. Sin square A plus cos square A is equal to 1. So you can write instead of sin square A plus cos square A, there 1. So in the next step, it will be 1 plus 2 sin A cosec A plus 2 cos A sec A plus cosec square A plus sec square A. You wait a minute. Okay, so you got sine square A plus cos square A plus 2 sin A cos A, sorry, 2 sin A cos sec A plus 2 cos A sec A plus cosec square A plus sec square A. That means in the next step you can write sine square A plus cos square A equal to 1. Okay, your next step will be 1 plus 2 sin A cosec A plus 2 cos A sec A plus cosec square A plus sec square A. Okay, in the next step we'll be changing cosec A as 1 by sin A. See, this term will change as its reciprocal. Reciprocal of cosec is sine. So in the next step, I'll be writing 1 by sine for cosec A as 1 by sin A. Cos. Okay. So cosec square A, I'll change as 1 plus cot square A and sec square A, I'll change as 1 plus tan square A. So right, changing cosec A equal to 1 by sin A. Then we'll change sec A equal to 1 by cos A cosec square A equal to 1 plus cot square A, then sec square A is equal to 1 plus tan square A. So from this step, we'll change all the cosec, sec, cosec square A and sec square A. So cosec will change as 1 by sin A, sec will change as 1 by cos A, cosec square A will change as 1 plus cot square A and sec square A will change as 1 plus tan square A. So the next step will be 1 plus 2 sin A into cosec we are changing as 1 by sin A. So 2 sin A into 1 by sin A plus 2 cos A into sec we are changing as 1 by cos A into 1 by cos A plus cosec square A we are writing as 1 plus cot square A plus sec square A we can write as 1 plus tan square A. So everything I have replaced. Now see here, sin A got cancelled. Sin A on the numerator and sin A on the denominator got cancelled. Cos A got cancelled. Now add all the numbers here. See, 1 plus 2 plus 2 plus 1 plus 1. Add all the numbers. 1 plus 2, 3. 3 plus 2, 5. 5 plus 1, 6. 6 plus 1, 7. So the number is 7. In the next step, you can write 7 plus, see, this got cancelled. Everything is got cancelled. What is remaining? Cot square A plus tan square A. 7 plus cot square A plus tan square A is the remaining terms. So we got 7 plus cot square A plus tan square A. See the question, RHS side is what? 7 plus tan square A plus cot square A, which is equal to RHS. Hence proved. Okay, from here you add all the numbers. So you'll get 7. Then only cot square A and tan square A is remaining. So it will be 7 plus cot square A plus tan square A, which is equal to RHS. So we'll move to the next question. Question number 9. Ninth one, cosec A minus sin A into sec A minus cos A equal to 1 by tan A plus cot A. So here first we'll simplify LHS side and then we'll simplify RHS side. Finally, we'll see whether LHS equal to RHS or not. So first start with the LHS side. That is cosec A minus sin A into sec A minus cos A. So LHS equal to cosec A minus sin A into sec A minus cos A. Below that, write changing cosec A equal to 1 by sin A and sec A equal to 1 by cos A. So from here we will change cosec and also sec as the reciprocal. So reciprocal of cosec is sin. So we'll write cosec A equal to 1 by sin A and we'll change sec A as 1 by cos A. So in the next step you can write, instead of cosec A, I'm writing 1 by sin A minus sin A. This is in the bracket. Again sec I'm changing as 1 by cos A minus cos A. Now taking the LCM. See here, into sin A into sin A, numerator and denominator, so that the denominator will be same. Here into cos A into cos A, both numerator and denominator. Now the next step will be 1 minus, see here, sin A into sin A, sin square A divided by what is the common denominator, sin A, sin A. So I can write 1 sin A here. Next one, 1 minus cos A into cos A will be cos square A divided by common denominator cos A. So I got 1 minus sin square A by sin A into 1 minus cos square A by cos A. So first I have changed cosec in terms of sign, that is cosec theta is equal, cosec A is equal to 1 by sin A. Then I have changed ck in terms of cos, ck is equal to 1 by cos A. So I got 1 by sin A minus sin A into 1 by cos A minus cos A. After that I have taken the LCM. That means I have multiplied numerator and denominator by sin A for the first term, and for the second one I have multiplied numerator and denominator by cos A. So I got 1 minus sin square A divided by sin A into 1 minus cos square A divided by cos A. Before that, we'll change. See, 1 minus square A. According to our identity number 1, we can replace square A as cos square A. And also see here, 1 minus cos square A is equal to sin square A. Right? 1 minus sin square A is cos square A. 1 minus cos square A is sin square A. So you can replace both. So for the first term, you can write here cos square A. Second one will be sin square A. So in the next step, you write, since 1 minus sin square A equal to cos square A and 1 minus cos square A equal to sin square A, so you can write 1 minus sin square A equal to cos square A. So first term will be cos square A divided by sin A into 1 minus cos square A will become sin square A. So it will be sin square A divided by cos A. Now you can cancel cos and cos, sin and sin. See, here cos on the denominator side and one cos on the numerator side. One sign on the denominator side and one sign on the numerator side. I'll explain it more clearly. See, this can be written as, in the next step you can write, see, cos square A you can write as cos A into cos A. That is cos square A into sin square A you can write as sin A into sin A. I'm simply expanding it, sin A into sin A divided by what is there, sin A into cos A. I've written it together. Say from here you can cancel cos A from the numerator, cos A from the denominator, sin A from the numerator, sin A from the denominator. Now what else is remaining? Only cos A into sin A on the numerator side is remaining. Denominator both got cancelled. What is remaining? Only this and this term. So cos A into sin A is remaining. So you got LHS equal to cos A into sin A. So keep it there. Now we'll solve RHS. Okay, LHS we got cos A into sin A. Okay, now RHS. What is our RHS? 1 by tan A plus cot A. So write RHS equal to 1 by tan A plus cot A. And right there, changing tan A equal to sin A by cos A and cot A equal to cos A by sin A. Okay, from here we'll change tan A as sin A by cos A and cot A as cos A by sin A. Right, sin A by cos A plus cot A will be divided by sin A. Denominator is cos A, here it is sin A. We need to make it same. So we will cross multiply. That means here we will multiply by sin A into sin A. This side will multiply by cos A into cos A. Cross multiplication. So therefore it will be 1 by, see, sin A into sin A will be sin square A plus, here you can see cos A into cos A, cos square A divided by what is the common denominator? Sin A into cos A, sin A into cos A. So I can write here sin A into cos A. That is the common denominator. So we got 1 by sin square A plus cos square A divided by sin A into cos A. Okay, so we got 1 by sin square A plus cos square A divided by sin A into cos A. That means this term will go up. See, this is 1 by 1. This is the whole division. So this denominator will go this side and it will become reciprocal. Sin square A plus cos square A by sin A cos A will become sin A cos A by sin square A plus cos square A. And also this division will be multiplication. So your next step will be 1 by 1 into reciprocal of the denominator. Sin A into cos A divided by sin square A plus cos square A. See, we know sin square A plus cos square A is 1 according to identity number 1. So right here, since sin square A plus cos square A equal to 1, that means this denominator became 1. Now what is remaining? Only the numerator. Sin A into cos A. This is your LHS. That is also equal to RHS. So finally you can write sin A into cos A equal to LHS, hence proved. LHS equal to RHS. Both we got sin A into cos A. Therefore, LHS equal to RHS, hence proved. Okay, the last question number 10 of this chapter. Take one. Plus tan square A. 1 plus tan square A by 1 plus cot square A equal to 1 minus tan A by 1 minus cot A whole square equal to tan square A. This is the last question of this chapter. So we'll start with 1 plus tan square A by 1 plus cot square A. Below that, write changing cot square A equal to 1 by tan square A. So in the next step, change cot as 1 by tan. So it will be 1 plus tan square A divided by 1 plus cot square A, you write as 1 by tan square A. Now I am taking the LCM here into tan square A into tan square A. So it will be 1 plus tan square A divided by 1 into tan square A, you can write as tan square A plus 1 divided by the common denominator, that is tan square A. So I got 1 plus tan square A by tan square A plus 1 by tan square A. One plus tan square A by tan square A plus 1 by tan square A. So I am taking this whole denominator to this side. So it will be 1 plus tan square A divided by 1 into reciprocal of this term. Tan square A divided by tan square A plus 1. Now see here, 1 plus tan square A, 1 plus tan square A. Tan square A plus 1 is also 1 plus tan square A. So you can cancel both 1 plus tan square A and tan square A plus 1. Now what else is remaining? Only tan square A equal to tan square A. See the question. See, you need to prove it is equal to tan square A. So we proved the first one, 1 plus tan square A by 1 plus cot square A equal to tan square A. Now we need to prove the second one. See the middle one, 1 minus tan A by 1 minus cot A whole square equal to tan square A. So now we prove the first one. Now come to the second term, that is 1 minus tan A by 1 minus cot A whole square. Okay, next one, 1 minus tan A by 1 minus cot A whole square. So this one, change cot A as 1 by tan A. So right there, changing cot A equal to 1 by tan A. Then write next step, which is equal to 1 minus tan A. This whole square we can give to both numerator and denominator. So I'm giving it individually to both numerator and denominator, divided by 1 minus, see cot A you can write as expand it a square minus 2ab plus identity a minus b whole square. That is a square minus 2ab, 2 into 1 into tan a plus b square means tan square a. Same way tan a minus b whole square, a square minus 2ab, 2 into 1 into 1 by tan a plus b square, 1 by tan a whole square. That means 1 by tan square a. See, I have expanded a minus b whole square. Copy down first. We'll finish this one. So by expanding, you'll get 1 minus 2 tan a plus tan square a divided by 1 minus 2 by tan a plus 1 by tan square a. Okay. So you got 1 square means you can write 1 minus 2 tan a plus tan square a divided by 1 minus 2 by tan a. 2 into 1 by tan a you can write as 2 by tan a plus 1 by tan square a. Now making the denominator same. See, here it is tan square a. I need to make all the denominator in terms of tan square a. So I'm multiplying here by tan a, here by tan square a to make denominator tan square a. Both numerator and denominator into tan a. So that the denominator will be tan square a, which is equal to 1 minus 2 tan a plus tan square a divided by, see tan square a into 1, tan square a minus 2 tan a plus 1 divided by the common denominator tan a. Only 2 more minutes, we will wind up the class. Okay, so you got 1 minus 2 tan A plus tan square A divided by tan square A minus
Hello.
2 tan A. Hello. Huh? Hello. So by this we have finished the chapter trigonometry. So you can go through the summary part. We have covered everything. Sin A equal to opposite side by hypotenuse, cos A equal to adjacent side by hypotenuse, tan A equal to opposite side by adjacent side. Second one, cosec equal to 1 by sin A reciprocals, sec equal to 1 by cos, tan equal to 1 by cot, and also you can write tan equal to sin by cos. If one of the trigonometric ratios of an acute angle is known, the remaining trigonometric ratios of the angles can be easily determined. We have done examples of that also. Fourth one, the values of trigonometric ratios for angles 0 degree, 30 degree, 45, 60, 90. We have done that also. Fifth one, the value of sin A or cos A never exceeds 1. Value of sec A or cosec A always greater than or equal to 1. Sixth one is not there in your syllabus. It is cancelled. Seventh one, identity number 1, sin square A plus cos square A equal to 1. Then identity number 2, sec square A minus tan square A equal to 1. Identity number 3, cosec square A equal to 1 plus cot square A. So by this we have finished the chapter. So in the next class we will start with another chapter. Chapter number 6, triangles. So that's enough for today. You all can leave the meeting.
Okay, ma'am.
Okay,
Thank
ma'am.
you.
Thank you, ma'am.
Thank you, ma'am. Yeah, welcome.